Hi everyone. So for this video, I am going to briefly talk about my project and how I did it, how the model looks like, and I will also mention something that I didn't add into my model that could be done in the future to make some more improvements. So first thing first, I uploaded all the data files as you all did. There are 8 in total, and after going through all of them, I first made some changes on the column names to make them more distinguished. Then I created a new data frame to separate year, month, and day for both reservation and visiting time. After that, I combined the air store ID with its visiting time, visitor amount, store genre, store area, etc. all together in one data frame. One thing I would like to clarify here is that when I try to match HPG store ID with air store ID, I figured most of them don't share the same ID. So I decided to focus on stores in the air system for this project. Okay, let's go through the data visualization. Here's a graph of daily visitors in a month. Since only 15 days in this chosen month are on record, the index has a range of 15, not 30, as you can see from the graph. And there are 2 peaks and 2 low points. Both peaks occur on Friday and Saturday, and low points occur on Monday and Tuesday. I also did a graph of daily visitors in a week, just to see the difference, like the trend. And the peak occurs on Friday. The low point occurs on Tuesday, which is kind of same as the month one. Then I used a mathematical formula to test if holiday is a factor that could affect the daily visiting. But the z-score turned out to be negative 0.17, which indicates the holiday is not a factor. I also wanted to know if each month has different performance that indicates month is a factor. Because sometimes you want to go out in autumn or spring. It's too cold to go outside in winter. So I calculate the mean of each month and get the following plot. And you can see in May and June, these are the 2 low points. Like there are very few visitors in the restaurant. And in March, there are very high, big amount of people that would want to go in March. Okay, so I also wanted to see the number of days between reservation date and visiting date, which is shown in this graph. The reason the notion of x-axis is small is that I first plotted a graph from the original data, but there was an outlier, 391. That means there was a visitor who made the reservation more than a year before he physically goes to the restaurant. So I plotted this graph to make it more distinguished because I deleted the outlier. As you can see, normally people like to make the reservation 1 day before they go to the restaurant. Okay, so let's talk about model. I chose a specific store ID and try to get the forecast of this store. I think this is a better way than doing forecasts for all the stores at the same time, because that wouldn't improve any efficiency for specific store. First, I got a decomposition of trend, seasonal, and noise. And from this plot, we can tell that there is a generally increasing trend, but not really obvious, like really good trend like this way, but yeah, there is a trend. And there is seasonality in seasonal part. Then I used hot winter method to do the forecast. And this is how it looks like. We can see that there is a great possibility that the daily visiting for the store would increase to a certain amount in the future dates. Then I built a Riemann model for the order 111, but the p-value is too small, which should not be used. So I decided to use auto-Riemann to select the order automatically, which is 411. And this time everything looks good, As you can see, the standardized residuals, ACF of residuals, p-values, they all look good. And this is the Riemann forecast. Okay, to sum up, the model did fine on forecasting specific store, but there are still some improvements that I could make to make the model more reliable. First, a Riemann method is best on forecasting stationary time series, but the data I used for this project could be non-stationary. And also, I didn't consider all the factors in this model, such as physical location and restaurant genre, which could make the forecast more accurate and comprehensive. What is more, I could try to do transformation on certain variables, which might as well make the model more complete. Thank you, and that's my presentation.